Okay, here's business. So your exam is in recitation Friday and Monday. And so we'll have today's stuff and homework due Friday, which is on the stuff on the exam, and then we'll tie up loose ends Friday in lecture. And then we'll definitely be through everything we need for the exam. And so in terms of support for that, so you've got exam prep. Exam prep over here on the left, remember, has, go to exam 1. So comprehensive bullet point outline is first, then the quizzes. So all 3 quizzes and solutions to those. Actually, the solutions will be released. No, that's something else. Okay, but you have all 3 quizzes and the solutions, and then some sample items. Okay, but it's not a whole practice test. It's just to get you the feel of the test and give you a little practice on some things. The answers version of that will be, this should say Thursday. Okay, so or Wednesday, Thursday, tomorrow night. So so work on it without having the answers. That's going to be your best way to utilize that. And then after you've worked on it, this should say Thursday here, tomorrow night at 7 p.m. I'll release answers to that. And then this inverse and compensation practice sheet will be a written homework for Friday, and that's all really important for the exam. And we'll get started on it in class today. And then we'll go over it more on Friday after you've worked on it and turned it in. Okay, and so then in terms of help, of course, there's the Tutor Center. Open 9 to 6 today, open 9 to 6 tomorrow. And then, let's see, you are in there tomorrow from 4 to 5. Is that right? And then I have just normal office hours tomorrow from 3 to 4:30 in my regular office. So I'm in the Tutor Center 10 to 11, which will be good for Monday recitation people, but not Friday. But then my normal office hours, Tuesdays and Thursdays, 3 to 4:30 in ECA 209. So study on the front end, study now, and then you've got time to get support, get help, and figure out the things that you're not understanding fully so that you can do better on the exam. Okay, find people, LP, myself, Tutor Center, to have these conversations with before the exam, not after. Okay, that will increase your score greatly. Questions on the exam? Oh, so I think you'll go on both Friday and Monday. Go to recitation 15 minutes early so you have extra time on the test. So we'll start at 10:15, and then hopefully we can also go 15 minutes after it's over. So it would take up some of the passing period time. But so the exam will start at 10:15 Friday and Monday. Other questions about the exam or getting ready for the exam? Yes, sir.
Is there any other resource then that'd be good for more practice problems and things like that?
So all the written homework from the book, all the web work is available, so you can find more stuff. Like all the odd number, I didn't assign many odds in the book because those solutions are online. So all those odd numbers that are similar to the evens that I assigned would all be good. Yeah. Other questions? Okay, so let's jump into it here. We're gonna be going on to the last topic before the first exam, but it definitely is using a lot of this composition stuff. So let's look at this example. This is somewhere in Investigation 5 in Module 3. And it talks about this conversion formula that gives you Fahrenheit given a Celsius degrees. And so they made that into a function here. G of C equals 9/5 C plus 32. So the input of this function is temperature in degrees, what? Celsius. The output is temperature in degrees. So, but there's no F there. Where does Fahrenheit show up in this function definition? Where does Fahrenheit degrees show up? G of C, right? The function notation represents the output quantity of the relationship, right? So the output quantity is represented by function notation. That G of C, that is our F. Okay, so for instance, G of 100 means what? So without finding a number, G of 100 means is what? How could you describe what G of 100 is? Exactly, and someone said over here too. This is a Fahrenheit degree measure. This is the output of G, or the degrees Fahrenheit, when the degrees Celsius is 100. Okay, and then to find that, we know we substitute 100 in for C, and so we'll get 9/5 times 100 plus 32, and that ends up being 212 degrees Fahrenheit is the same temperature as 100 degrees Celsius. Okay. So let's look at this and let's talk about, we have G of C equals 9/5 C plus 32. So what process does the rule carry out in order to do this? In order to convert Celsius to Fahrenheit, the rule takes us through some steps in order to accomplish that. What's the first thing the rule does to the input? What's the first thing the rule does to the input? Multiplies by 9/5. We're going to write that out. So you're going to multiply the input by 9/5. And then what's the next thing that the rule does in this conversion process from Celsius to Fahrenheit? Adds 32. So add 32 to the result. So if we were going to think about a process that did the reverse, that took degrees Fahrenheit and gave you degrees Celsius, it would just be the reverse of this process that we wrote out. So I'll do that in red. So the reverse process would start with what? Degrees Celsius or degrees Fahrenheit? Degrees Fahrenheit. Okay, that would now be the input, degrees Fahrenheit. And what if we were reversing what we just wrote out here? What would it do first? Subtract 32. So subtract 32 from the input. And then it would, you could say multiply by 5/9 or divide by 9/5. And I'm going to do that to be very, very literal here. The second thing it would do would divide the result by 9/5. So maybe we'll call that reverse process H. And what's the input into H? F. And so now we just do to F exactly what it says here. First thing is we'll take the input and subtract 32. And then next, divide that by. So what do? We just came up with a rule that reverse. Oh, that's supposed to be, shoot. So this is all supposed to be a different color. But anyway, so the reverse process reverses, now it takes Fahrenheit and returns back the original Celsius degrees by subtracting 32, dividing by 9/5, because that's our original rule in reverse. So if I were to start with some Celsius temperature and put it into G, that would give me what?
Fair.
The corresponding Fahrenheit. Now what if I took that g of c then and put it into the function h? What would happen? Which Celsius? Which Celsius would it give me? The one that I started with, right? So if I put Celsius into this function that gives me Fahrenheit, the corresponding Fahrenheit, and I put that Fahrenheit into the h function, it's going to take me back and give me the original C I started with, right? Okay, so prove it. So this is like what we did in class Monday and what you did in your homework. So algebraically, find what that is. Algebraically, work out this left side of this. And when you algebraically work it out, you're expecting to get? What are you expecting to get in the end? You should get C. So if you do the math right, you should get C, because that's exactly what that expresses. It expresses putting C into this process that gives Fahrenheit and taking that and putting it into the process that gives corresponding Celsius, which should be what we started with. So you're going to show that algebraically. That's called a mathematical proof. Mathematical proof. So what does it mean? What does h of g of c mean given these two rules down here? So given these two rules for h of c and g of c and h of f, what does that mean, and can you work out the algebra? Okay, so if some of you know how to get started, others may not, so get help, okay? So ask the person next to you, work together, talk it out. So what does h of g of c, how can we start? What does h of g of c mean? It means h of 9/5 c plus, that's how you should have started. And what does h say? H says take the input, subtract 32, and divide by 9/5, right? Take the input, subtract 32, divide by 9/5. So we take this input and we do what? Subtract 30, here's the take the input, subtract 32, and divide by 9/5. So now we can simplify the numerator. The numerator is just 9/5 c, because 30 plus 32 minus 32 is 0 over 9/5 over 9/5 is equals, did it. Okay, so for your own practice, you do it later. So if you do g of h of f. So here, what's this say? Take a Fahrenheit, don't do it now. Take a Fahrenheit degrees and put it into the function h. What will you get? You put a Fahrenheit into function h. What does it give you? The corresponding Celsius. And I'm going to take that and put it into g. What am I going to get? Which Fahrenheit? The one I started with, right? So I'm going to put, if I put f through h and then take that result, put it through g, it's just going to give me the Fahrenheit I started with. And so you can prove it later. Oh. So what are we saying? We're saying that that thing equals f, and we're saying prove it later. So you're going to do the same. The same idea of algebraically working through g of h of f and showing mathematically that it does always give you back the original f you started with. Okay, so it's a similar exercise to that. Okay, very good. So let's talk. Symbolism here. So we had g of c and then we had h of f. But there's kind of a standard notation for inverse. So here's our original function. And we use this notation right here to mean g inverse, or the inverse function. What is the inverse function? It's the function that reverses or undoes what the original function did. So if g does a process, g inverse reverses that process or undoes what g did. And this is the notation for that. This does not mean an exponent. It's not an exponent to the -1. So it's not reciprocal. It's not 1 over. So make sure that then that's confusing, but I didn't make it up. It's just the practice that kind of evolved, that this is the notation they use. This is not an exponent. It looks like it, but it's not. It's the notation to mean g together with that -1 means the inverse function of g. In this case, what we called h before, what we called h of f. Okay, and so then generalizing even more from that, we could say g of x. And g of x would be 9/5 x plus 32. And what would x represent in this case? X is degrees Celsius. That's what g did. It took degrees Celsius and gave Fahrenheit. So x is kind of generically used for input. So you'll often see then this. Then you'll see g inverse of x. And that would be our 5/9 x minus 32. That's the same as dividing by 9/5. Multiplying by 5/9. Before we had it as dividing by 9/5. So we're using the same symbol x, but now it's the input into g inverse. So it's not the same. Now what is x in this function? It's degrees Fahrenheit, okay? So you have to, because x is kind of generically used always to mean input, you have to know what the function, exactly what the input and output quantities of the function are, so you're correctly interpreting x in any given situation. In g, the input is degrees Celsius, so if it's g of x, then x means degrees Celsius. But now, if it was g inverse x, x is a different quantity. It's the output of g, okay, which was Fahrenheit. Now it becomes the input of g inverse. Okay, so does the notation make sense? So you have to really identify, always know what your quantities are, your input and output quantities of whatever function you're dealing with, whether it's the original function or the inverse. Okay, so I got a fancy PowerPoint for you. So just as a reminder, we say f inverse of x. This represents the inverse function of f of x. It does not mean 1 divided by the output of f. Make sure you're confident with that. It's not an exponent to the -1. It means the inverse function. Okay, so let's look at a couple of perspectives here. So the first perspective of f inverse is it's the reverse process of f. It's the reverse process of f. So if you have like think of it as the machine, input into f, f cranks on the input and spits out an output, then one way to think of the inverse is that it's running the machine backwards. You're going to take whatever output quantity you had for f, and that now is the input, and you're going to run the machine backwards, and you're going to your output then is going to be like the input of f. So you think about cranking the machine backwards. Reverse process. Okay, so in that case, look, the output. This is the output. It seems simple, but when we get into problems, it gets confusing. The output of f is the same quantity as the input of f inverse. Makes sense? And so then the output of f inverse is the same quantity as the input of f. Okay, makes sense? So therefore, when you see notation like this, you have the function f, but you can also talk about the function f inverse in this notation. So you are going to take a second to say where in this notation do you see the input of f, the output of f, but then also where in this notation do you see the input of f inverse and the output of f inverse? So I think that's so. Yeah. So you're saying in this notation, where do you see the input of f, the output of f, but also where do you see the input of f inverse and the output of f inverse? Take a minute to talk to the person next to you. Talk this through. Where do you see all four of those quantities? Go. Almost done? You're good. I'll just wait. So are these alphabetized then? Are they alphabetized? Oh, okay. So we have to do that next. You almost done? Let's record it. Keep going. Okay, so F should be we all should have this down. Where do you see the input of F in this notation? X. Where do you see the output of F? The whole thing, F of X. Okay, so given that F inverse is the reverse process, then where do you see the input of F inverse in this notation? The whole thing. Since it's the same as the output of F, the input of F inverse would be the whole thing, F of X. And where do we see the output of F inverse? X. Okay. It seems simple now, but when we get to the problem, when we get to the exercises, you have to have this down. You have to have this down. Okay, same thing. Now you have, where do you see the input of F and the output of F? The input of F inverse and the output of F inverse. Go, take a minute. Talk it out. Oh, okay. Okay, where do you see the input of, let's do F inverse first. Where do you see the input of F inverse? The input of F inverse. X. Right. Where do you see the output of F inverse? The whole thing, F inverse X. Okay, so now F. Where is the input of F? Where do you see the input of F? The whole thing, F inverse X. And where do you see the output of F? X. Okay, so let's practice. So in your, what page is this on? In that investigation 5, there should be a table and these same problems. Yeah, right there. What page is that? 107. So here on, you have this table, and the table gives you information about the function f and the function g. But these are all related, most of these are related to the inverse functions. So that's why we need what we just did on the previous screen. So when you look at this g inverse of 3, you need to interpret this in terms of the function g. Where is that? Do you see the input of g? Where do you see the input of g in g inverse 3? Where is the input?
The entire output of the function g.
107? Was it?
It's the entire output of the function.
The entire thing. It would be the input, and then where do you see the output of g? 3. So this expression is asking for the input of g when the output of g is 3. It's backwards, right? Because this is g inverse, and we need it in terms of g. So this whole thing is saying, what is the input of g when its output is 3? So now we look at the table. What is the input of g when its output is 3? You look at the output of g is 3, and its input is -1. So the answer to A is -1. Does it make sense? So practice this input-output stuff, and you have to do things in terms of F and G because that's the information you have. So that's why you have to do that, kind of go through that, what we just went through to answer it. So work on B through F. Again, I encourage you, talk them out together. I don't hear much talking. Get a partner, work them out together, talk. What's that? Yeah, geometrically. Okay, so let's you do E. Let's do E together. E. So take 30 more seconds. If you haven't worked on E yet, go to E and see if you can get E, and then we'll talk about that in a moment. Okay, so what do we start with? G inverse or F inverse in that? What comes first? F inverse. And so F inverse of 6 is what about F? F inverse of 6 is talking about what about F?
Input of F when the output is 6.
She said the input of F when the output of F is 6. That's what F inverse of 6 is. Agree? Well said. F inverse of 6 is the input of 6 when the output of F is 6. So we look at the table. What is the input of F when the output is 6? 2. So now we have G inverse of 2. What is that talking about relative to G? G inverse of 2 means what about G? She said the input of G when the output is 2. G inverse of 2 is the input of G when G's output is 2. Agree? All right, so what is the input of G to get an output of 2? 0. Answer to E is 0. Does it make sense? Questions? Anybody have a question? C, sure. So hopefully that one we could, so now that we got an inverse, now the stuff from before is a little more confusing. That's okay. So what do we do first, F or G? What comes first, F or G? G comes first. And so we're talking about G of 0. G of 0 is what relative to G? G of 0 is what quantity relative to the function G? Input. It's the input of G. G of 0. Is that right? G of 0. Is that the input or output of G? Output of G. It's not talking about inverse function. It's just straight up G of G. What function notation gives the output of a function? And if it's G of 0 and we're talking about G, then G of 0 is the output of G when its input is 0. And what is that from the table? 2. The output of G when its input is 0 is 2. And so therefore this is the same as F of 2. And what is F of 2 relative to the function F? Output or input of F? F of 2. Output of F. That's what we worked on the last week and a half. F of 2 would be the output of F when its input is 2, which is? 6. Right. So F of G of 0 is 6. Can we go on? So that's one perspective on this. That is the reverse process. When you reverse the process, your output of F becomes your input of F inverse. Those quantities are the same. And then the output of F inverse becomes the same quantity as the input of F. That's thinking about F inverse as reverse. Okay? The other way to think about it is what we kind of started thinking about it as undoing. Undoing, right? So if you have F that takes X and gives you F of X, then you have a new function, what, that undoes that process. If you give the output of F and you put it into F inverse, you're going to get X. So this is the idea that it's a new function that just undoes what the other one did. It's a slightly different perspective on inverse. So can you write out function notation that represents that whole diagram? Can you use function notation to represent what that whole diagram says? See if you can do it. Think about it. How can you use function notation to represent what that whole picture is showing? Anyone think they got it? So what process comes first here? F of X. So really, the key to doing this is focusing right here. This is really the key to writing this out. What are we doing with the output of F? Yeah, so you're doing what? Say it.
You're
You're
gonna funnel it through the inverse of f.
going to take the output of f and funnel it through the inverse of f. So what would that be in function notation? How would you write that all out?
Inverse of f.
The negative one, right? F inverse or f of x equals x.
F inverse of f of x equals x. That's what that picture says. That whole illustration shows you that you're taking the output of f and you're putting it into the inverse of f and you're getting back x. And that's we showed that algebraically with the Celsius and Fahrenheit. We worked it out. Okay? This is the coolest thing you're going to see all day. All right, ready? So if f inverse undoes f, then that also means that f undoes f inverse. Did you see that? That's right. Oh, too slow. Went back too far. Okay, so if f inverse undoes f, then f undoes f inverse. So we could show it like this. Ooh, cool. So that means that f undoes f inverse. And so if you were writing that function notation out, what would it be? F of f inverse of x equals x. So that's also true. That's also true. If A undoes B, then B undoes A. Okay? So if F undoes F inverse, then F inverse undoes F. Or the other way around. Okay, so let's practice some more of those. If you look in your book. There's the table. Look for the volume of the sphere. This one. But I'm going to change, we're just going to work on writing the undoing process, writing the new function that undoes the old one. So this function takes radius as input, and it generates or it outputs the volume of the sphere with that radius. So here's what I want you to do. First thing I want you to do is write out the rule. In words, step by step. Okay, so it might not take 4 steps. However many, it takes 2, it takes 3, it takes 4, whatever it takes. You're going to write out the rule process. And then, so that's number 1. Number 1, you're going to write out the rule process. Number 2, you're going to write out the undoing, the rule process that undoes that. Whatever it takes. And then, from that, then you're going to write f inverse, and we'll just say f inverse of x. You're going to write, define the function. So this is what we did like earlier when we did the Fahrenheit and Celsius. So 3 things you're going to do. First, you're going to write out the rule process. That rule takes input and does what to it? 1 step at a time. Then you write out the process that undoes that initial rule process and use that set of steps to define the inverse function for this. Is the task clear? As always, work together if you need to. Talk it out. Okay, so we gotta do this efficiently. So this is one homework that we're turning back. It's alphabetized, mostly, okay? So within a certain letter that may be off. So when you get to your letter, look around, okay? But it's for the most part alphabetized. So find yours fast, pass it on so we can get this done by the end. This one too. Leave the rubber band on and just flip through. Start this and back. Okay, what is the rule process? First, does what to the input? What happens first? Cube the input. So that's what you should have had first, or cube R. What's next? Okay, yeah, so you can do this in 2 steps, or you can just do this all in 1 step, because really 4/3 pi is just a multiplier. It's just a coefficient. So if we want, we can, but I'm guessing most of you did it 2 steps, so we'll do it that way. So multiply by pi, and then multiply by. But I could have made my step 2, I could have made it multiply by 4/3 pi, and you would have been done. It could have made 2 steps, but this is fine. This is, I'm assuming most of you did it. So therefore, what process would undo that? We have an input here, and we would start by doing what? Divide by 4/3, then divide by pi, and then cube root whatever you have at this point. So cube root the result of 2. So now we're gonna define the function f inverse just by creating an algebraic expression exactly like this pattern of the process that we did. So it's going to start with x and do what first? Divide by 4/3, and then divide by pi. So we need the pi down here, and finally cube root the whole thing. And that's the definition of the undoing process. So what is the input and output of f inverse? What quantity is the input and output of f inverse? Input is, in this situation, he wants volume. Agree with that? It's going to be the same. How would you find out? The input of f inverse is the same as the output of f. That's what we ended up with in f. Now we're going to undo it. So the input into f inverse is volume. Volume of a sphere. Output, corresponding radius. And that's the rule that does it. That's the rule that takes the volume and outputs the radius of the sphere. Questions on that? So I want you to do this. Yeah, please.
For the second part, you divide 4/3 to the output, right?
Well, so when you start with the undoing process, you're going to start with the input of that is going to be the output of the first one. So I'm calling the input. So the input of f inverse is what you. So the output. So this gives the output of f, and we're going to start with that, which is the input of f inverse. Start working on that. So we're dividing the input by 4/3, which was the output of that. Does that answer it?
Yeah, because like the last example we did, it just said the output.
It just said the output.
Well, the output of that, which is the input. So
Yeah. So the output of f is the same as the input of f inverse, and that's where we're starting with when you do that undoing process. One more example of that. So I think if the next page, or a little bit further ahead, is this one. 2x minus 5 over 6. So, write out steps. For the rule. Write out steps to undo it, to undo the rule. And then define F inverse based on number 2. Then I have Courtney. Where's Courtney? And Tristan. Tristan here? And either one. Read that. Hand that back to Courtney, please. Back to the back up. And that's back, also back up. Okay, so keep passing that homework. Find yours, pass it on. How are we doing with those? Okay, so what does this do? What does F do first? Multiply by 2. Next? Subtracts 5. Then? Divide by 6. Therefore, reverse rule is going to multiply by 6, add 5, divide by 2. So can you come up with F inverse of x is going to take x and do what first? 6x plus 5 all over 2. That's the function that undoes this function or reverses it. It's called the inverse function. Okay, so let me need to finish attendance, sorry.